Now on to parametric equations and trying to find polar equivalents of simple equations. Now we know that in the not so polar form, this is the equation of a circle. Okay, so this is a circle. The first part is a circle that is centered on the origin and it has a radius 5, and algebraically we know we write it as such. Now, what sort of parameterization of x and y could apply to this and give us this condition? We can use this identity. We know that cos square x plus sine square x equals 1. Here our parameter would also not be x, it would be theta. So we're increasing the theta, but we're increasing it in the opposite direction, sort of clockwise. So we need to put an x value over here, so we can write it 5 cosine of theta, because you see the cos component would, or the x component would first decrease and then increase in the negative direction, and then decrease in the negative direction, and then increase in the positive direction, which is the same as it would be in the clockwise case. So therefore I use the same x parameterization. For the y parameterization, I would use y equals minus 5 sine theta. Why would I do that? Is because y starts from a negative value this time over and not from a positive value. So as y is starting from a negative value, my assumption is that I can use the negative of sine. If I were to evaluate this, 5 squared from both sides would be common, and then there would be cos squared theta plus sine squared theta, which is 1, and you'll get 5 squared theta. Therefore, this is a correct parameterization of the equation, because it should follow the rule in the other coordinate system, which is the Cartesian system. So therefore y equals minus 5 sine theta and x equals 5 cosine theta. Okay. What about a vertical line that passes through x equals 2? This is your standard xy axis. This is the point 2, and then there's a vertical line going through that. How do you parameterize it? Now, of course, if you were to see it in sort of a polar sense, not exactly in a polar sense, what is happening to the x and y coordinates? If the line is oriented upward, or in a sense moving upwards, one thing is fixed, which is x. So x of t is a constant function, which is 2. Okay. What about y? Now y of t is increasing. Okay. And to make sure that you're getting through all the points linearly, what you can do is apply y of t equals a linear function in t, and that would be it. So you use this sort of parameterization for straight lines passing vertically upwards, and a similar method is used for straight lines that are passing horizontally.